coming along. Next presentation today, we've got Raina
Eschrich, yes.
From Oracle Corporation, and Thomas Hott from ProSyst, and they're going to talk to us about smart and highly scalable lifecycle management for embedded devices. So without further ado, I'll hand over to you, and if there's any questions at the end, I'll come up and assist. Thank you.
Yeah, thank you for showing up. I have the pleasure to give you the first part of the presentation. Obviously, you see, I'm from Oracle, used to be a Sun guy, and you see I'm Java. So I'm from a unit within Oracle, not so famous. I'm from the global Java sales unit. So we sell Java, unbelievable, especially for embedded markets. And our main task is to evangelize Java usage across all usage cases. So one slide I have to give you, the safe harbor statement. Whenever I make a mistake, you have to look here. All what I say is not right depending on this. It's the one slide which will be in every Oracle presentation you have ever seen and will ever see. So I have to put it in. So I will put the framing, I give it roughly 10 minutes, and then Thomas will take you into the details. I will explain to you why something, especially for OSGi, why it's well positioned and why it's very important to have something like a resource management for it, remote management. So, where are we? So, I've done at Sun embedded Java for quite a long time. So I'm doing this more than 8 years now. Something happened in the while that we saw that a lot of use cases were in the area of M2M, so machine-to-machine communication. So why started people to look at Java? I think, first of all, a lot of people from university came and they just could program in Java, not in C, so they took Java. And another thing, the use cases became more complex. And why do they become more complex? Because we approach slowly what we call the Internet of Things. So some people claim it's already here. I don't believe this. We are still at least 10 years away, but it will come. And why is it different from the classical embedded world or the M2M world? Because we suddenly talk about smart devices. And that especially should make the OSGi guys really, really happy, because you will have applications on the thing and not on the laptop or on the server. But you will have it on the thing, which gives you a huge audience and a huge possibility for products. So it doesn't actually, at the moment, from my projections, goes down to the sensor or the actor yet. If you talk to guys like Bosch, and they don't put it in this little knot yet. Eventually wind up there as well, but at least in the gateway kind of thing device. So what does it mean? It's a huge complexity thing. So suddenly you need a lot of things to consider in an architecture which the embedded guys and even the M2M guys never had to consider. And that is it, the smart. So how does it happen? So if you look it up, I would argue that almost none of the technology needed for the Internet of Things is not already there. So I say, okay, we already have all pieces. However, we don't know how the pieces fit together. And of course, there is missing a lot of clue. And so we are actually in a status where I would say we transition roughly from the PC in this Internet of Thingy thing, which Netscape made. So suddenly we need standard protocols, other stuff to come up. And Oracle's huge push, and believe me, if you don't see it, it's like a huge thing coming in the market, is to bet and get a platform done there. So Oracle's history, of course, is more around the data. So what's the thing? What is the thinking Oracle does? We want to help people manage the complexity on the data level. So which data in this huge data stream? And if you look at it, at the moment, without Internet of Things, data rate in the Internet doubles by every 6 to 7 months. So it's faster than the CPU can double. It's faster than RAM can double. So it doubles faster than everything else. If you add Internet of Things, I think you might get at least another factor of 2. So that means data rate will double by a factor of 2 every 3 months. And then you suddenly need something to process in an intelligent way. Because in the past, a lot of people just took all the data, stored it, and eventually 3 years later thought about how to work with this data. This will not work in the future because nobody can store it anymore. It will be just too expensive to store all data. So what does it do? So the Internet of Things platform from Oracle lives on the application layer and the data layer, obviously. So we think the first important step, of course, is acquire and manage. So you need to take the data up. You need to talk about in the devices, and there, of course, you need a scalable platform. And surprise, the answer is Java. Yes, so that's my part. So we strongly think that Java, because it's available for many platforms, it can be extended to almost anything to run from nowadays with JavaME 8, from 256K up to, I don't know, TerraRAM or HeptaRAM or whatever comes afterwards, so with the JavaEE. And it doesn't mean that your code will run on the smallest device the same as on the biggest device, but we will be able to reuse the stack. And a big part of it, of course, is OSGi, because you know how to package code. You make it smaller, you make it scalable, and then you can add layers the more you go back away from the edge. So this slide, I don't need to tell you this slide. I mean, I left it in because it's one of my convincing slides for the embedded world. So whenever you talk to a classical embedded developer, might not happen too often, I talk to them a lot, they're usually C or assembler guys. And they always ask me, Rainer, what is the value of this Java thing? It's slower, okay, maybe 10% header. So it's more complex, yes it is, you have to learn the tools. C is simpler if you do simple things. Though, but there is a huge thing. You forget about your fixed solution, fixed problem solution. So embedded classically, and M2M is still the same. You think about, you know everything which will happen in the next 10 years. With Java you agree, or you make a contract with your device so that you don't know what will happen with the device in the next 10 years. You give it a service platform. You know there will be new things happening over time. And it's actually the same which made Web 2.0 or now HTML5 so big on the browser, because you don't know what will happen. What will be the next Google? Nobody knows. And in the next 10 years, we will most probably see somebody there. Why not on the device? Classical devices go in the market. If you buy a car nowadays, for now, the telematics device has been designed 3 to 4 years ago. It's fixed. You can't upgrade it. You can replace it. You buy another box for $3,000 maybe, but you can't upgrade it, and that kind of doesn't make sense in the future. And that's what Java plus OSGi gives you for the embedded guys. So for you, maybe new, because the embedded people still think it's a traditional way. The next thing after you've done it, you have acquired all the data, you have your applications who hopefully analyze the data, you have to integrate it and secure. And then the larger Oracle people come up. That's where we see the web layer. It's a SOA classical architecture, and it has to learn a lot of things for Internet of Things, because one of the very important things, if you talk about billions of devices, how do you manage the identity, and how do you manage the security? Look at Java at the moment with the client certificates and the browser. You still have a human being. A device doesn't have a human being necessarily to be able to analyze what's happening. So this is something we have to learn and extend, and Oracle is doing a bet there in this area. And then, of course, the last is analyze and act. If you're not a developer but a business guy, and you have to shell off the money to make a prototype for this, you want to be convinced that it has a value for you. It has to bring some certain thing, and at the end, the value of all this Internet of Things is in the data layer, in the analysis. So there must be a business case, and if you can't analyze your data, you don't have a business case. And that's something where the big Oracle comes in with the Exadata and the fast data. So that's the complete architecture. It still has a lot of holes and a very schematic architecture. We're version 0.1 maybe, very early. But we have a lot of ideas how to fill the blocks. So there is a deeper architecture I'm not allowed to show you yet. And a huge role in this, of course, is Java on many levels with OSGi. And that is the end of my framing. Another very important part is that Oracle delivers this usually in a box. And that's the idea what we are doing here. You might have heard about the Exadata or the Exalogic. The idea is to integrate this all. So we are aiming to build something like an IoT in a box, basically a solution which you can do in a virtual machine or on a hardware optimized for this case. Okay, this is my part. I hand over to Thomas to give you the details why you need a management for all of this and how it works.
Thanks a lot, Rainer. Just go back one slide here. I think it's an important slide. And also show
Just wait a second.
Oh yeah, right.
You need this.
Yeah. Where do we put this?
Somewhere.
Somewhere here? Oh, it's inside then. Anyway. All right.
You want a mouse?
Okay, yeah, why not? Okay, I think this is an important thing. I mean, this is sort of the entire end-to-end architecture here for on Oracle's view. And my company, ProSyst, we are very in a lucky position that we fit in very well in here, on the middleware part. I mean, this picture has been shown before. That's kind of now as an example, a smart home scenario where you basically have a gateway here, and Dimitar was talking yesterday about the connection to all sorts of protocols in the local area network. Then you have to get to the end user via some GUI. And what I would like to talk to you now is basically about the remote management side, yeah, because that's one of the beauties of OSGi. And so far, you know, when I was at all these conferences, we were very much talking about this part, the OSGi platform and so on. But now we've got many projects where all of a sudden, you know, we don't only have 100 or 1,000 or 10,000 of devices that need to be managed in a scalable, in a very efficient way. And that's what I would like to focus on today. So, we basically, introduce a product of us, but there are many of remote management systems around. From people like Motive and IBM and Motorola and so on. I'm obviously present more with what we've got. It's called mPRM. It's maybe a little bit of a stupid name, but comes for historic reasons, called Empower Remote Manager. Let's call it mPRM. And this is basically a management and monitoring system that supports remote device management, software provisioning, service operation support, also user management for all sorts of devices, not only for OSGi-based devices, but also for JavaEE, for native components, and so on. The main features here are obviously centralized device configuration management, software management, provisioning, the automatic software compatibility and dependency resolving, which is very important in the case of OSGi, monitoring of the runtime status, performance of devices, remote diagnostic, remote device and application control, data retrieval, very important. And getting even, that's actually one of the main reasons I see right now for OSGi, you basically need a local intelligence somehow to process data, to filter data. So in the old world, in the old M2M world, you had fairly stupid actors and sensors out in the field, and everything, all the intelligence was in the cloud. The situation here reminds me very much to the PCs in the early 80s, where all of a sudden people realized that it makes a lot of sense to have more intelligence locally. And one of the reasons to have this technology in the local area network is this massive amount of data which can't really be managed without being filtered locally, so that you get really information into the cloud instead of raw data. The product Rationale, I mean, why did we develop this thing? We had more and more clients that, like Deutsche Telekom, T-Systems, and on the telematics side, actually quite a few companies doing fleet management, remote diagnostic of car data, driver behavior, and so on. These guys, they basically wanted to, I'm on the wrong slide here. They needed to operate all these devices, and they needed to install new software components. They have to start, stop, update the software components, configure the platforms, define control and access rights, so who's allowed to do what, resolve the dependencies, device and application performance troubleshooting, very important, because the system has to be very reliable, And these kind of things are the rationale for this remote management system. The service providers obviously want to provide services remotely. They want to manage the user subscriptions, deliver the services, obtain the service usage information and the billing information. And obviously the end users in the end, they can, via such a system, can get the devices automatically registered, review and subscribe, receive upgrades and updates, and also get all sorts of troubleshooting and maintenance services from the operator and service provider. When we started the whole thing, so I would say more than 10 years ago, we really underestimated that these now are called advantages, but I think it's more, these are requirements, that if you have large deployments, and it's not so difficult to manage a few devices, but if you have large deployments, you have to make sure it's really scalable. You can not only manage 100,000 or a couple of millions, you have to manage 10 millions of devices in a very efficient and secure way. It has to be very reliable. Availability has to be close to 100%. It has to be extended. It has to be modular to fit into existing backend architectures. And that's quite a challenge to build such a thing, and took us quite a while. But yeah, we've done a pretty good job there, I think. We can talk quite a long time about the architecture. I just wanted to give you a certain idea. And the first message really is that this enterprise system was probably the first enterprise system that was entirely built on OSGi. Yeah? So it's very modular. It runs on an OSGi framework and has various packages and modules. The main modules here are the modules managing various types of devices. So we have one system here that is able to manage mobile devices, smartphones or mobile units in cars via OMA-DM, the Open Mobile Alliance standard. You can also have broadband routers, DSL routers managed via TR69. We also have proprietary management protocols that are very efficient. We can not only manage these kind of platforms, but we can also may have a native package, can flash devices or even non-OSGi devices. So as I mentioned, midlets, JavaME, midlets can be managed with the system. So that's I think, something no other system is offering right now. And we feel that's also talking to our customers, that's a very big advantage that you have in the end one system that can manage the software in your car, the software in your home, and software you might have some other networks. Obviously, other packages, basically the basic function, generic device management package, there's a software repository package, user management package. There has to be integration into existing J2EE servers. I just have a look at a few of those modules. I think the management operation is one of the key modules here, because if you want to really execute the software download, in reality you have to be able to have various classes of devices. You have to set commands which group of devices shall be updated. Maybe you just update all the devices that have a certain virtual machine running, or you have only the devices in the Stuttgart area, and all these things can be done. Another thing is obviously whether you want to have an instant execution and what you do about the devices that are offline now, so that you have a persistent queuing, that you can report which devices have been updated and which not, and the respective GUI and scripting tools for the management operator, for the operators. The software repository, maybe I don't really read through all of that. I think it's clear that the trick is really to have software repositories and then kind of a smart deployment whenever something in the software repository changes. That's also something which was a customer request, that basically if there is a change in some type of software in some software repository, the system automatically detects which devices in the field need that upgrade and smartly deploys these upgrades. The user management, another very important thing, so that you really can define remotely as an operator. You make the decision how the authentication process works, the passwords, the certificates, or other credentials, all the basic profile properties, then up to user preferences. That's all basically things that can be done here. There are a number of other features. Again, we have a very comprehensive online documentation. If you're really interested in it, just scroll through it. I don't want to make this too technical here, but just give you kind of an overview on what it really is. The architecture itself looks actually not so complicated. We have basically just three parts that are important here. The management server is basically the connection to the gateway. On the gateway itself, we have an agent running that connects and that can manage all the properties and software on the devices. Then the remote access, basically in the control center, is the border to the outside world, to the management operators, and obviously then the third-party data bank servers. That's where Oracle comes into play. What's also maybe important to mention is that this is a very open system. It has a lot of very open APIs, which makes it very easy for operators to integrate this backend system into their existing enterprise systems. And there's also something what we have done in a couple of very complex cases, like with Deutsche Telekom, and has worked because of this very open API structure very, very well. Now, if you have a kind of, and that's what we had in the beginning, fairly small scale deployments up to, let's say, 1,000 or 10,000 single gateways in the field. It basically is sufficient if you have one backend server which you run somewhere, and and then you can connect this to the M console or web portal, and you're basically set. And that works pretty well out of the box, and can actually be tried out. I'll come back to this later. With a large-scale deployment, that's not a trivial task, but that's something which basically is achieved through a very good cluster architecture, where you can then involve a lot of backend server hosts, and each one managing a large amount of devices and gateways, but it's still a very consistent model, and it's still ensuring the optimal distribution of the load among the different backend hosts and databases, and provides a very efficient data exchange. Now, back to Oracle. We have not really any customers right now who have more than millions of devices. So, but we obviously want to still tell our customers that we are very scalable. So we partner up with Oracle, and we went to their Scottish labs earlier this year, and we did a fairly extensive benchmarking. I think the benchmarking report in the end was more than 100 pages, really lining out how well the backend system was running on the Oracle Exalogic Exadata products. And the benchmarking also produced some very concrete results. So we were able to show that, I started with more than 4 million online devices could be managed on one Exalogic H rack, which is quite impressive. And these racks can be really big, and it was very impressive to see them at Java 1. The performance was just excellent. We could really, you can read the numbers yourself. We could do really thousands of firmware updates, of software updates per second, and the whole thing is really very reliable, very scalable, and whoever's interested can also have more details about the report. We also did an official press release, which was pretty well received. That's where we partner pretty well with Oracle, I must say, and obviously this fits very well our middleware. The backend system fits with their backend products, and on the client side, we run best on the Java SE on Oracle's virtual machine, and so this all fits pretty well together. I'd really like to invite all of you to try it out. I mean, if you go to our website under cloud.prosyst.com, you can yourself basically have access to a cloud-based remote management system, and you can connect your devices and can play around with it and can see how it works. It's very well defined on our website. And again, I didn't have the time. I didn't want to go. I'm not a technical guy too deeply into the technical details, but here I think you get a very good feel what you can do with it and how well it works. So I mean, I have probably now, still 8 minutes, but I'm already here at my summary. The system we are offering here is a very cost-efficient system to manage basically almost unlimited numbers of devices. It is one solution that really covers all the functional aspects you really need, which is the management of the devices, of the management of the users, and the management of the software, the services. It's really easy to deploy, so your time to market is very fast, and it's very reliable. So, I mean, in any scenario, it's a little bit like Rainer said. The scalability is key today, because once you have a solution, a telco has a solution, or car manufacturers delivers a car, there are no new requests, new features the customers want. So in the end, the scalability and the remote manageability are the key two features you need in IoT. That's basically all I've got to say. I'm a bit early, but that also leaves us some time for questions.
Thank you very much. Are there any questions for Thomas or Rainer? Nothing? I've got one. So you say it's very cost effective.
Yeah.
In terms of using it with Exadata, I mean, Exadata's, I guess,
not
a top end platform. So I guess that sort of thing is aimed more at the service providers, is it, in terms of being cost effective? It's not. Because there's lots of nodes on the end of an Exadata, aren't there?
I mean, as you've seen, one Exadata and one Exalogic gives you 4 million concurrent devices. So adds more to service providers.
Yeah.
However, I mean, it's very interesting because at the moment we are in a roughly 1-to-1 rate. So one human has one device roughly. Worldwide. We're not talking Europe and US. Worldwide. We're going strongly in a 1-to-2, and there are predictions, depending where you listen to, that like by 2020 we have a 1-to-10 at least. So the telcos nowadays and a lot of service providers who want to enter this space have really the problem that if they scale up their classical NEP infrastructure, they would have to pay like the 10 times what they already pay, and they couldn't even afford LTE. So how do they afford this? You know, it's not that you get the 10-time amount of new contracts out of it. So you have to have a cost-efficient solution. However, it runs on a laptop. So if you want to try it out, first of all, it runs in the cloud, but it runs on a laptop. So for a small-scale deployment, you know, it's very simple.
Yeah, and actually, I mean, if you try it out, it's obviously for free, so very cost-efficient. And and then, I mean, if you compare it with our competitors, some of the friendly competitors I named in the beginning, if you go to them and say, I manage 10,000 of devices, and the price tag is pretty high. Yeah, and we have many customers who basically do a little fleet management operation for a garbage collector in Trier or whatever. Yeah, I mean, so they have maybe 100 devices or 1,000 devices, and they can run it on a PC more or less. And
so the solution will scale depending on
yeah. Obviously, if we go into the millions and tens of millions, you need an infrastructure that will cost something.
Yeah. Look, I also want to mention one thing here. For the developers, and I expect most of you are developers, that changes something, because in the past you really knew what will happen on your thing. In the Internet of Things world, the unknown is really what you will expect. So because what I've seen is that integrating many different services from many different companies on the backend side didn't really work very well. In the Internet of Things, I think you have to really consider this cross, and a provisioning system gives you a straightforward road where you can try out to provision your, 3 developers sit together and try to provision their OSGi service on the same device, same time, or maybe 100, and try out whether this really works. And I think this is a good way to try out, also for a developer, how it really works, how the workflow is in reality. Because the time where you sit with a laptop in front of a device and, put it like this, it's gone. I mean, as nice as Raspberry Pi and other things are, this is not how the world will work. It doesn't work, because not all of them will be open, most of them won't. So you have to go through one of these funnels, like from the Apple idea that you have a shop, you have to publish, and then it goes down. And that is one of the publishing mechanisms, and you have to learn it and do it.
Any other questions?
Do we easily integrate this product? And suppose you have a device that's already running on an OSGi container, can you actually just take the product and the bundle and just deploy it on a device like that? Or does it have specific requirements from the OSGi environment, from the device?
No, not really. I mean, you have to run the system agent, the agent on the bundle, and then
You can just take the bundle, just deploy it, and that's it.
that should work. Yeah.
So we could also.
Yeah.
Yeah, secret source is the agent. It has to run well on this OSGi container you are doing, and it has to know a bit about how the local deployment really works. But outside of this, it's fine.
Any more questions? No? Thank you very much.
Okay. Thank you.